Hi, in this video, we are going to look at a calculus problem, and the question goes like this. Let the function y is equal to f of x satisfy dy by dx is equal to y plus integral from 0 to 1 y dx and f of 0 is equal to 1. Now we have to select the right options. Option A is f double dash 0 is 2 by 3 minus e. Option B is f of 1 is e plus 1 by 3 minus e. Option C is limit x tends to 0, f of x minus 1 by x is equal to 2 by 3 minus e. And option D says half of f dash of ln of 3 minus e is equal to 1. So let's think about how we will solve this question. It is given that f of 0 is 1. So that is some information, and this relation is satisfied by the function, right? Now think about it. Whenever I say integral 0 to 1 y dx, technically you know that it is the area under y is equal to fx graph from x goes from 0 to 1, right? So this area value will be a constant. It will be some number, right? It will be a constant number. So it is not a function. That's what I mean to say. So therefore, what we can say is, let's call this constant as k. For now, we are calling capital K as the constant, which is the area under the y is equal to fx graph from x is equal to 0 to x is equal to 1, right? In that case, my differential equation here is looking like dy by dx is equal to y plus k, right? And this is actually a pretty simple differential equation to solve because it is in the standard form of a linear differential equation. We have this looks like this. The integrating function of this is e power minus x. This is my if, and the solution for this will be y into e power minus x is equal to integral of k into e power minus x dx, right? So the solution for this will become y into e power minus x is equal to minus k into e power minus x plus c, right? And therefore y should become minus k plus c into e power x, right? So this is becoming my function. And now what we know is f of 0 is equal to 1. So basically that means y of 0 is 1. So 1 is equal to minus k plus c into e power 0. So that means c minus k is equal to 1. And that means the constant c is equal to k plus 1, right? So the constant c is becoming k plus 1. And therefore my function y is k plus 1 e power x minus k, right? So far what have we done? We called k as the value of the integral y dx from 0 to 1. And using that, we got a differential equation which we solved by the normal method for solving linear differential equations. We did it by the integrating factor method, right? And from there, we got this as the function. And given the data in the question that y f of 0 was 1, we got the value of constant c. And that constant became k plus 1. Now that we have a function looking like this, we can actually find the value of k because we can use this and this, the definition of the function and the value of the area under the function from 0 to 1, right? So what we can say is integral of y dx from 0 to 1 is equal to k, which implies integral of 0 to 1 k plus 1 e power x minus k dx is equal to k, right? So this is easily integrable and you will be able to solve it. So you'll get k plus 1 e power x minus kx evaluated from 0 to 1, that value must be equal to k, right? So this will become k plus 1 into e minus k plus 1 into 1, and that's it. So is equal to k. So we have this is minus 2k minus 1 is equal to k, and this is k plus 1 into e. So you're getting k plus 1 into e is equal to 3k plus 1. So if we want to find the value of k, what I will do is solve for k. So I will get k e plus e is equal to 3k plus 1. So k common e minus 3 is equal to 1 minus e. And therefore k is coming out to be 1 minus e by 1 minus e minus 3. And notice that both of these are negative. So it can be written as e minus 1 by 3 minus e. That is my k value, right? Once we know our k value, I can find the function. So the function that we had was y is equal to k plus 1 e power x. The function that we had gotten was what? C is k plus 1 e power x minus k. That was my function. And I know k value. So what is k plus 1? It is e minus 1 plus 3 minus e divided by 3 minus e. So that is clearly 2 by 3 minus e. So 2 by 3 minus e power x minus k, which is e minus 1 by 3 minus e. So it is 2 e power x by 3 minus e plus 1 minus e by 3 minus e, right? So that is becoming my y after putting in the value of k that we just now found, right? So this becomes my function, and now my job is to figure out the options, which options are correct. You can easily check that if you put x is equal to 1 here, you get 2e by 3 minus e plus 1 minus e by 3 minus e. So it becomes 2e plus 1 minus e, so 1 plus e by 3 minus e. So that is going to give you option B. And after that, you have to verify the derivatives. So let's check all the options. You have y is equal to 2 e power x by 3 minus e plus 1 minus e by 3 minus e. So y dash is going to be 2 by 3 minus e power x, and y double dash is going to be 2 by 3 minus e. That's it. 2 by 3 minus e power x. This is also going to be the same thing because the derivative of this is going to be the same, right? So now that we know y dash and y double dash, we can check y double dash at 0 is 2 by 3 minus e. We can also check from here that y of 1 is equal to 1 plus e by 3 minus e. These are two of the options, okay? And then we have to find the limit of, this is option A, by the way. This is option B. We have to find the limit of x tends to 0, f of x minus 1 by x. And this is in the form 0 by 0 because f of 0 is 0. So this is going to be by L'Hopital's rule f dash x by 1. So it is going to be f dash 0. So f dash 0 in this function, if I put 0, the f dash 0 is 2 by 3 minus e itself, right? So this limit is 2 by 3 minus e. So that becomes your option C. And finally, I have to check option D, where we have half of f dash of ln 3 minus e, right? So f dash function is this. And if I do 2 by 3 minus e, I want to find f dash of ln 3 minus e. So I have to do 2 by 3 minus e into e power ln 3 minus e, which is going to be 3 minus e, and that will cancel and become a 2, right? So this thing is going to be 2, so half of that is going to be 1. So the last option is also correct, and you get A, B, C, D as the answers for this particular problem. Now, remember this technique. This is a very standard question that has been asked before as well. You have a function whose definition involves an integral of the same function. Here, for example, we had dy by dx is equal to y plus integral of y itself, right? So this integral, this part is a constant and you can assume it as k and solve the differential equation dy by dx is y plus k. And later from that solution, you can find the value of k because k is equal to integral 0 1 y dx, right? Whatever comes from here, you will put that from here into here. And then you will find the value of k and that will give you the function, and that's how we solve this problem. So I hope you learned something from this video. That's it for now. I'll see you in the next problem.